done. I don't know, it's letting folks in very slowly this morning. All right, good morning, everybody. I'm going to put up a discussion question for you. We kind of skipped a unit, but they're connected. So we were talking um, on Monday about renewable and non-renewable energy. So we need to backtrack to the unit before it and talk about energy in general. So what I'm going to do, so if you go into Canvas, there's a discussion question, and I'm going to pull it up and share right now that I want everybody to take a look at. All right, so again, if you go into Canvas, you should see there's a discussion question ready for you. So if you click on discussions, it should be the circle of life. So I'm looking at student view right now. And if you click on circle of life, there's a question for you. It says there's two circles in the diagram below. Discuss two factors about each circle. So basically it looks like one big circle, but as you see, there's a pathway in between. So discuss the top circle and the bottom circle. So list two facts about that you can see about each circle. So that's your warm-up activity. And then we're going to, from there, that same circle is in the module. So we're going to do energy flow. So we kind of skipped ahead a little bit, but we're going to stop here and do energy flow. And as you see, the same picture is in your energy flow. Okay. All right. But you start with discussion. I think everybody's in, so I don't have to repeat this. All right. So take the next few minutes to submit this discussion question. All right. So I'm going to come out, do attendance while you do that. Again, you're just looking at the circles are divided by the arrow that goes from right to left. So think of that as part, but it's really one big circle, but it kind of represents two pathways. So take a look at it, and based on kind of things that we talked about yesterday. All right, so as soon as you finish that, submit, and then we'll go on to today's lesson. All right, we got quite a few people missing, so I'm going to give it another few minutes before I start. All right, so I did have somebody to come in, and then somebody else asking a question, what you're doing. All right, so right now, like I said, I'm looking at the student view. So you need to click on discussion. And in your discussion, you want the first one at the top, circle of life. And you're looking at the diagram and it says there are two, so it looks like one big circle. And actually it has titles on it. Two sides, top and the bottom. One top part of the circle is labeled matter. This bottom part is labeled energy. So when you answer the question, it says there are two cycles showing in this diagram. Discuss two facts about each cycle. So I'm again, the line going through across this middle of the big circle kind of divides the matter circle from the energy circle. So explain what you see. This is just a warm up. Okay, explain what you see as far as what is happening in the top circle as it relates to matter and what is happening in the bottom circle as it relates to energy. That's your question. So you want to answer that now. Give you another 5 minutes, and then we're going to go on. And then that needs to be submitted. That's a graded assignment, so submit it. Okay? That's the warm-up question. Oops, sorry about that. Keep forgetting my screen shares both. All right, so again, what if you're looking at the course structure, I accidentally, because it wasn't downloaded, I accidentally skipped over energy flow and ecosystem. So we started 2 sections of energy consumption, but we need to go back and talk about what is energy before we do that. So you're working on Circle of Life, then I want you to, if you finish that early, go to the first unit in the module, which is the overview, and you'll see there's the same picture. And then there are the vocabulary words. So look at that while you're waiting for us to get started. I have somebody else to admit. All right, so again, if you finish answering your discussion question, go ahead and look at the first, the overview lesson for energy flow in an ecosystem, EFE, energy flow in an ecosystem. Look that over again. Like I said, you'll see the same discussion picture, and then come down and look over the vocabulary words. Class started like 14 minutes ago. You're late. So I can go back in and mark you late, but you're late because they've already done a whole assignment in this time already. I'm gonna stop sharing so that I can fix the attendance. You got 5 minutes. And I'm gonna say this for everybody. You got 5 minutes grace. Class started at 10:10, so that meant at 10:15 I can mark you absent. All right, I corrected it to tardy. So you, all right, because right now you just came in and you don't even know what we're doing. 10 o'clock. I have 10:10. I saw a lot of you were logged in. I did see that. I thought, you're right. So I was actually late. I mean, I was in and I saw all of you in, and I thought all of you were just early. Okay, I've corrected that on my schedule. So 10 o'clock. So that means you're super late. All right, it's 10:10. Let me make sure I have that. I did have that last week. Yeah, today I don't know why I wrote that down 10:10 today. Sorry about that. But it is 10:26 right now. So yes, class started at 10 o'clock. Okay, that being said, let's go on. So I'm going to come back to share the module. So hopefully everybody's had a chance to turn in their discussion question. Okay, so again, the discussion question was based on this picture, and you notice the top part of, so it states that there are, compare the 2 cycles. So the top cycle has matter, and the bottom cycle, it talks about energy. So that's what we're going to be looking at, the relationship between living things in an ecosystem and the non-living things in an ecosystem. So again, at the top, one of the vocabulary words that you've had before that you need to be aware of are biotic and abiotic. So your biotic are your living things, and that would be everything on the bottom half of the circle. And your abiotic materials, and that's everything on the top half of the circle. But it's all in one circle, indicating that we need all of these things. We need both the living and the non-living things in order for life to take place. All right, so I'm not going to go through that right now because I want to see your discussion questions first, in case anybody hasn't sent their discussion question in yet. I'm not going to give you the answers. All right, so what we need to look at right now is we need to define what is energy and how do organisms get it. And again, this page has a list of the vocabulary words. All right, so I'm going to the next page, which is actually the first page. All right, so we first need to define what is energy. Oops, my volume. Okay. All right, so basically, what did that tell you? It asked a question, what do you need to sleep? And I know you think when you're sleeping, your body's not doing anything. Your body's doing a lot of things while you're sleeping. And then it said food. What did that mean to you? Give me a second. I need to change this so I can see everybody. Okay, so right now I see like there's 3 people off camera. All right, last time, folks, there were a couple of y'all who were logged in, but Go Guardian said that you were idle for most of the class. You got to participate. You got to participate. You got to be doing something. Otherwise, you're really not present. Okay. All right. So basically, it said you needed food for energy. So you're going to eat. The reason you eat is because your body needs energy. All of your life cycles while you're sleeping, your body is growing, repairing, it's doing a lot of things, and all of those activities need energy, even though you are in, say, I got somebody else just coming in class half over. Okay. Um, but you need energy. You need energy. Okay, so let's look at defining the types of energy. So actually, let me come back. Um, we get our energy from the foods that we eat, but we need a definition for energy. Trying to highlight. All right, somewhere it should tell you energy is the ability to do work. So write that down somewhere. Let me go back to the first page and see if it tells you that there. Energy is defined in scientific terms as the ability to do work. And there's 2 types of energy. No, it doesn't. Yes, it is. Okay, let's look at, well, they've got a real fancy definition for this. Okay, but it's the ability to do work. And it says a quantitative, that means that you can measure it, of how much of something that can be transferred from one object in order to perform work or heat on another object. Okay, so in other words, we're going to take in food for fuel, and then we're going to transfer the energy that is stored in that food to your muscles, to your cells, to your eyelids. It said if you yawn, to your jaw muscles. So the energy that you take in the food is transferred so that you can perform some type of work. Also, in the process of doing that, your body gives off heat. So that's, in a nutshell, that's what that definition is telling you, that it is a measurable amount. That's what they mean by quantitative property that can be transferred from one object to another object to perform work. All right, so that's what we're going to be looking at. And so coming back to the page. All All right, this is telling you that there are two types of energy. There's kinetic energy. So you need to make a note of this. And that's the energy of movement. Okay. The key word here in kinetic energy is it is an energy in motion. Okay. The object is moving, it's doing something. All right, so it says, for example, food is digested, the bonds are broken down, and the stored energy is converted to cellular energy, which allows the cells to perform the task. The task, again, is the work that it needs to do, meaning the cells need to divide or reproduce. They need to move around, and you need to, for your muscles need to move, your lungs need to take in oxygen. All of that requires energy. So, think back to biology. You were told about ATP. ATP is an energy molecule and it's stored in the bonds of the molecule. So when you eat that hamburger and you break it down, you're going to break down it into proteins. Well, there are amino acids that are linked together. And in order to break those up, you need energy so that you can rearrange those molecules to make new proteins. So that requires energy. So that's kinetic energy, energy of motion. Then you have potential energy. Like somebody tells you you have potential, that means it's in you, it's stored in you, you're just not using it. Okay. All right. So again, here with potential energy, the key word is stored in the object. The energy is there and it needs to be released. It has the potential to do some work. All right. So it says you've eaten the food and the food has chemical bonds and this energy is just there until you digest it. So just getting it in your stomach is not enough. You've got to digest it, break it down and release those bonds in order for it to do you any good. Otherwise, it's not going to give you any energy at all. But it has the ability to do that. So it's got potential. All right. There are several types of energy, and then I believe the list on the first page goes through and defines each of these. And you might have done this in physical science. I know when I taught physical science, we had to go through each type of energy, as well as talking about potential and kinetic energy. So there's thermal energy, and that might be also called heat energy, radiant energy, which is what we get from the sun. Chemical energy, again, is coming from the foods that we eat. Nuclear energy, there are minerals that we mine up from the ground that can be used to, when we divide them, just dividing the for example, uranium is an element. If we divide it, we break it down, it is stored. It stores a tremendous amount of energy. So this is why a lot of the chemical plants are trying to move to nuclear energy, because you can get a lot more energy out of splitting an atom than you can burning coal. All right, electrical energy, almost all these kinds of energy can be converted to electrical energy. The energy of motion or kinetic energy, sound, elastic, like the energy. When you have a rubber band or something that is stretchy, while it's sitting, when you pull it out, you're storing the energy in it. And then when you let it go, like if you sling that rubber band at somebody, that's got a lot of energy in it. We used to, when I was doing physical science, we used to do the little go-karts, the Newton carts, they called them. And we just use rubber bands to make the cart. And you wind that rubber band up and you wind it up, and then it's storing energy. When you let the rubber band go, it sends the car clear across the gym. So it stored the energy while you were winding it and then released the energy when you let it go. Okay. All righty. All right. So again, energy is the ability to do work or bring about change. And it happens when the energy is transferred from one system to another. So if you haven't written that part down, that's something you need to write down. Okay. All right, so then it clarifies, redefines work. So now you have to have a scientific definition of work, and that is defined as what happens when energy is transferred from one system to another. Work is done. I think when we were doing physical science, I used to say if you got your hand leaning on the wall and you're pushing on this wall as hard as you can, but the wall doesn't move. So if the wall doesn't move, it doesn't no matter if your sweat is dripping off your brow while you're pushing. If the wall doesn't move, no work is done because it has to be transferred, and then you have to get a result from your transfer. So if it's not transferred, no work is done. Okay. The second object is said to have done the work if like I said, the energy is transferred to the other one. In ecosystems, energy, and this is the part we need because we're in environmental science. So we are concerned with light energy, heat energy, and chemical energy. And then specifically, we're going to be looking at photosynthesis and respiration because they are directly involved in storing the light energy and releasing the light energy. Okay. All right. So again, just look at these two. Let's see, how long is this video? Because we got like a minute. It's 2 minutes. All right, so this is where we'll pick up when I see you again tomorrow. All right. And again, this just basically reviews potential and kinetic energy. The law of conservation of energy, I'm sure you've heard this before. And we're going to keep on talking about this is why we have the circle of life, because all the energy in the universe is already here. We are not creating any more energy. Okay, it just keeps getting cycled and cycled and cycled. Okay, all righty. So I do apologize for having my schedule off, but I do believe we are on track now. Okay. All right, so 10:40. It's 10:40. Anybody have a question? The Zoom kicked you out. Okay, you're good. I know you were here. Yeah, the Zoom this week has been acting very strange. I think the other day I lucked out because I don't always turn my computer off, and because I left it on, you all were able to log in when a lot of the other classes were stuck because they needed to reset the passwords. But we're good. All right. So again, we're stopping here on the difference between potential and kinetic energy, and then we'll pick up on conservation of energy and look at energy relationships. Okay, okay, stop. All right, so that's where we'll pick up tomorrow. All right, you all have a great day. See you tomorrow.